In this video, we're going to look at magnetic force. And we're going to look at right hand, not right rand. Oh man, oops. Right hand rule. So hand rule 1. There are actually 3 right hand rules. We're going to do 2 and 3 in the next lesson. Okay, so first, a little bit of convention. If we're looking at something towards the top of the page, okay, or up, something like that, it's going to be north. So north is towards the top or up, something like that. If you use those words, think about like towards the top of your page. If you use north, think towards the top of your page. Okay. East is to the right, west is to the left, south is towards the bottom or down. Okay, those are just the words you're going to use. And you might say, oh, duh, now. But wait until you get these problems with like, this is up and this is down and this is left and this is right, or to the north and to the south in the next problem. And just keep in mind. Alright, and orient it with your page. If you have a piece of paper with, words on it, north or up is towards the top of the paper. South or down is towards the bottom of the paper. Right and left. Okay? Now there are 2 new symbols. The new symbols are into the board or into the page. So into whatever you're looking at, and O is out of whatever you're looking at. Okay? Now, there are a couple ways to remember this. 1, I remember O for out. They both look like O's. O means out. Another way is X marks the spot. So if you're on a treasure hunt, that's where you dig in. X is where you dig into something. So X is into the board or into the page, into whatever you're looking at. Okay? So north or up on whatever you're looking at. So if you're working on a worksheet, so let's say we're working on that same worksheet down here. X would be into the worksheet and O would be out of the worksheet. Okay, we're dealing with 6 different directions here. This is 3D. Alright, now the right hand rule number 1. Magnetic fields and magnetic forces are very complicated. If you have a charge moving through a magnetic field, it's going to feel a force. Okay? There's going to be a force on that magnetic field pushing it one way or another. It's really hard to kind of figure out what direction that force is acting in without a little bit of help, or a trick, in other words. Now you're going to be using your right hand for this. This is not math. Alright? This is your right hand. You're going to point your thumb in the direction of your force. Okay? So thumb, direction of force. Your pointer finger, okay, that's your index finger, your first finger, points in the direction of the velocity or the conventional current. Okay, you might want to add that in there. Conventional current. Okay, and your middle finger will point in the direction of your magnetic field. Okay, the symbol for magnetic field is B. In the last lesson, we drew magnetic field lines, right? We had magnets, and we drew magnetic field lines. Well, B is the direction that those magnetic field lines are pointing in. Okay, so if I had, let's say, a north pole of a magnet, and they were pointing out, the direction of the magnetic field would be in that direction. Alright, and the symbol for magnetic field is B. Okay, that's our new symbol. We're going to be using it throughout this unit. And I know it's not necessarily the easiest symbol to remember, but B is B. Alright, now, I told you had your thumb, your forefinger, and your middle finger. What you're going to do is put your hand in this position. Your thumb is going to be pointing up like a thumbs up. Your pointer finger is 90 degrees from it, so it's making like a right angle. Okay, so if you think about it, before you do your middle finger, those two fingers are like you're pointing a gun, like your fingers, you know, that kind of thing. And then you stick your middle finger straight out, perpendicular. So it makes 3 lines that are each perpendicular to each other. Now, your thumb points in the direction of your force. Your finger points in the direction that the charge is moving, so the direction of your velocity. And your middle finger points in the direction of the magnetic field. And if you move your hand around, okay, just move it around, you can see that you can point in all these different fun directions. Now be careful when you do this and where you are when you do this, and make sure that, you know, it doesn't look like you're making weird or bad gestures to your family, friends, pets, you know, grandmothers. They might feel a little upset about that. Alright, so this is the convention. You will always use this. The trick is remembering what you're using for what. I remember that the magnetic field is the middle finger, because the middle finger is the bad finger. Bad. B for bad. Magnetic field is B. B for bad. Works out. Okay. I remember that the pointer finger is the velocity, because you say, he went that way, and you point. He went that way. So that's the direction you're going. You point in the direction of movement. So that's the direction that the charge is moving in. And all that's left is force. I was also trying to think of another way for you to remember force, and I came up with that this thumb here looks a lot like an F. So that's the best I could come up with force. It's also the most forceful finger. You know, it's got the most strength, less likely to break. Okay, but really I just remember the other two, and then force just kind of comes. Okay, so let's give this a try. The force is into the page. Okay, so you can do this if you get a piece of paper and set it in front of you. You can do it into that piece of paper, or if you'd like, you can do it in relation to the screen and treat your screen like a piece of paper. Whatever works better for you is fine. Alright, but just stay consistent. So the force is into the page, into the paper, into the board. Okay, so into. So if we look at it this way, the force is into the page, and force is your thumb. So your thumb is going to point into. Now the magnetic field is pointing north. Oh, Smart is dropping the TI again. So that should be, I apologize, this is a conversion issue. That should be magnetic field is pointing north. It should be right on your paper. Okay, but the magnetic field, which is your middle finger, because that is your bad finger, bad finger, is pointing north or up. Up the screen, up to the top of your paper. Up. Okay, north or up. And they're looking for the direction that the proton is moving in. So we're looking for what direction our pointer finger is in. So take a second, pause this video. Please pause the video. Take a second and try it. Okay, you should have gotten that it is moving. Your pointer finger is that way. Okay, to the left. Alright. I know that was kind of an awkward position for your hands to go in. Some of them are easier, some of them are harder as far as position. If you didn't get that, try again. And when you have it set up, double check. Okay, so set up your hand. Double check. Is your thumb pointing into the page? Is your middle finger pointing up? Okay, your pointer finger should be pointing left. If you're using your right hand, also check to make sure you're using your right hand. If you're using your left hand, you will be backwards every single time. Okay. Once again, ignore the TI. I'm sorry, the software is currently dropping it, but the magnetic field in this case is pointing east. Okay, so your middle finger should point east or to the right. Alright, the proton is moving north, so your pointer finger should be pointing in the direction it's moving, so you should point north or up towards the top of the page, towards the top of the screen. And you're looking for the direction the force is acting. Take a second, pause the video, figure out what direction your thumb is in. Your thumb should be into the page or into the screen. Hopefully you got that. If not, stop, repeat, set your hands up, double check your fingers. Alright, now force is acting on a proton out of the page. So your force, so your thumb is out of the page. While, oops, that should be proton, is moving north or up the page. So it's moving, so that's the direction of movement, that's the direction that you point. Your pointer finger is up or north, and you're looking for the direction of the magnetic field. Okay, so give it a try. Pause the video and give it a try. That should be to the left, or to the west, or that way. If you got it wrong, stop, repeat, check your fingers, make sure you're using your right hand, not your left hand. Makes all the difference in the world. Alright, I'm going to give you a little bit of a show. These are things you might see. You can see them in word problems. You can also see them in picture problems. Alright, picture problems. When you see multiple dots or multiple lines, those are the magnetic fields. Because if you remember, when we drew a magnetic field, we draw multiple lines, right? So you'll see multiple lines or multiple dots, meaning that position. Velocity will be shown usually using a symbol like this, or it will be labeled as velocity. But the big key is, if there's multiple things, that's your magnetic field. Okay? One line is either the direction of the force or the direction of the velocity, depending on what you're told. In this case, it's kind of easy to see that they're the direction of the velocity. Alright, so pause, try this. I'm going to write down the direction. So give it a pause, try, see if you get them right. You should have gotten into and down. If not, go back, try again, repeat. Alright, the only difference here, that right hand rule works for protons or positive charges only. But what happens if it's an electron? Well, that's fairly simple. There are two ways to do it if you want to do it using an electron or a negative charge, something with a negative charge. One, you can flip your hands. If you do it with your left hand, you will always get the correct direction. So you can use your left hand. Or if you don't want to confuse yourself with two different hands, okay, you can use your right hand, and when you get the answer, flip it. So if it was left, it becomes right. If it was out, it becomes in. If it was north, it becomes south. Okay, both do the exact same thing. Left hand flips it, and so does making it the opposite. Alright, along with your homework, I want you to fill in this thinking map with the information I've already given you. If you have trouble, come see me before 7:17. I will be checking. Good luck on your homework.